We had Joseph and Monica, okay? It's Central Time, noon time. We'll get started. Usually on the Monday meeting, we primarily focus on question and answers, okay? So any questions so far? Joseph, you have question?
Nothing for me so far.
Okay, no problem. So we primarily, because we already had all of the course recording in the course share, so you can watch the video to learn the material that you need for the whole class, okay? And then Monday actually is a very precious time, so we use it primarily to answer the questions. And then because today we only have two people show up and then there's no question, so what I will do is just go over the concept beyond the course material, okay? To make sure that you know what we are doing and why we are doing these things, and also what's the benefit of doing the things that we want you to do. Okay. So first thing is that we would like to talk about mathematical modeling. Okay, mathematical modeling. Uh, Very surprisingly, this year we do have the Nobel Prize to award uh two scientists who work on the AI. Okay, so what I want to say first one is this one. And so AI and then physics. Is AI one kind of the physics? Okay, this actually is a question, right? This actually is a question. And then why AI is considered to be one kind of the physics, and also the two scientists they actually say that they don't like physics, and they become uh,
Om Shri Krishna.
pioneer for AI. Any question?
Join the meeting.
Any question? Krishna, do you have question?
No, no, Professor.
Okay, okay. Okay, no problem, okay? What happened is like physics, you do study the physical world, and then you use math to model the whole physical world. And so you need all kind of math to do it, okay? And then AI is what? You build a virtual world. This including AI. In AI actually means that including robotics, and then natural language processing, computer vision, all kind of things related to AI. It actually build a virtual world and also use a math. So the math they are using actually is the same. And then the kind of modeling they are doing actually also the same. So in a way, AI can mimic or regenerate the simulation of the real world physics, any kind of physics, okay? Because you are sharing the same math. That's what I want to say. So nowadays, we try to build a virtual world, and then physics is a tool that you need to study because you need to have the fundamental um, understanding of the mechanism. And basically, based on those understanding, you build a mathematical model and then go into the AI. Okay, that's what it is. So what is that related to MATLAB and Python? Okay, so MATLAB, some of you know, it actually is a, let me zoom in a little bit. It is an extensive library for data processing and plotting. Okay, so including the mathematical tools. It's called MATLAB. It's a metric lab. Okay, metric lab. So Python has a standard library. Okay, and then it's because MATLAB is a commercial tool, so MATLAB come with a lot of tool package. And then Python have the community also the tool package. Actually, it's free. Community means that a lot of people trying to do open source. Okay, anyway, this some main difference. But you do have the MATLAB ecosystem. If you buy the core MATLAB and then Simulink image processing toolkit, and nowadays they all have the AI or whatever tool packages. On the other hand, you can also use the free tool Python. You have NumPy, SciPy, Matplotlib, Python Qt, okay, and also Skit, ScienceKit, okay, ScienceKit, okay, also NumPy, SymPy, all kind of the different tool. Then you can have the similar ecosystem that MATLAB can do, okay, whatever. So, but you need to install a lot of things by yourself, okay. You need to install a lot of things by yourself in order to get, I don't say it's exactly the same, but similar ecosystem that you can have. And we pick Python language because of the free, okay, because it's open source algorithm, because it's free. So that's why we pick the Python ecosystem as our mathematical modeling tool, okay? And then we want you to program in Python, so you can get the same experience or similar experience that you can get from MATLAB, okay? That's the main purpose. And with that, you should be able to do a lot of things, okay? This article talk about a lot of things, but anyway, this is why we pick Python language and only take the .py file. Okay, we don't take the notebook file because we want you to do programming. We want you to use the toolkit. Okay. So if you don't have the toolkit ready, what should you do? Okay. So basically, let me show you here. Okay, let's go to my YouTube channel. Okay, my YouTube channel. My YouTube channel actually has many courses that I teach before. Okay, and then let me pick one. Okay. Okay, this is summer. I do have the data science course. This one I think that I post the link for you already. Okay. So the thing is like we do have the, let's see, software installation. So here we do have the Macintosh version installation. So if you need the installation guide to install the Python up to the level that you can operate the majority of the toolkit, we do have a video. You can actually look at it. Okay, you can look at it. And this is a playlist. Actually, last time I already give you the playlist. Let me actually post it one more time. I'm sorry. Okay, so this is the toolkit, and if you don't know about the language, this whole video. Okay, actually here we had a PC version as well, but it's titled in Chinese, but don't worry, okay? It actually is okay. We do have the English version of the installation guide. Okay, sorry. I do have some high school students. They are from Taiwan, and then in the summer I told them Python for data science. Anyway, what happened is like this actually will teach you the basic, very basic part. I think many of you actually already know about how to program in Python. That's not a problem. But my only issue is that you must have the whole package that you need for scientific calculation. Okay. So that means you will need to have Python core, plus NumPy, SciPy, and also Matplotlib. And then something good to have is like you knows SymPy, Pandas, okay, IPython, or Jupyter, or something else like Python Natural Language Kit, okay? They are similar package. And also if you heard of the tool called TensorFlow or PyTorch, okay, whatever, there are several tools that you can install by yourself, okay? Right here, I just list down some of the toolkits that you may need or in the future you may need, okay? And that will help you to learn AI and mathematical modeling, okay? Okay, and then that's the mathematical modeling part. As for mathematical background, okay, what kind of background you need, okay? Before we go into these different slices, let's look at another website. Okay, look at this guy. This is actually my younger son. I have two sons. One working for Visa. He's 25 years old. Okay, my elder son. This one is my younger son. He's 21 right now. Okay, and he studied at the Stanford Master Program. Before he go to Stanford, he actually is in the UC Berkeley MET program. Okay. UC Berkeley MET program, if you don't know, it actually is a dual degree program working on EECS, electrical engineering, computer science, and also business. Okay. And then he took a lot of course. I'll talk about the course later. Okay. So what I want to say is that I use his material to tell you what can be done in order to help your study in AI and robotics. Number one, you need to have a core programming experience. So during his high school days, he worked on Python, JavaScript, C++, and Java. Okay, Java, you have the AP ComSci A. Okay, so that's no problem. And Python and JavaScript, we teach him in AP ComSci principle. So these two he finished in high school, and then C++ he finished in Foothill College as a dual enrollment program. Okay, and besides that, he also took quite many math courses. I would say most of the math course required for college in Arizona State University. So that part is very important, okay? That's why I want to browse his resume to talk about it. So what kind of math you need to do the mathematical modeling before you come to the robotic course? I would say at least calculus. He took a brief calculus. This is AB version in high school. And then he also finished the BC in his own high school, but this one is in ASU. And then linear algebra, okay? And then calculus C, this one is actually the multivariable calculus and the linear algebra and differential equation, and also economy, economic. Economic is for mathematical modeling in the business world, okay? And then discrete math and math structure. This is abstract algebra. Usually is a college junior course, okay? So whatever He actually finished quite a lot of math course in ASU, and this is the foundation for math. Okay, so beyond this, in college you need to take okay. After all of these, in the college you also still need to take optimization theory and statistics or probability. Okay, and another course random process. These are math courses that you would need to finish. So go back to his engineering study. These are some core courses of CS in Berkeley. So he took probability theory and the discrete math, and then basic algorithm. Okay, this is actually not basic algorithm. This is algorithm analysis, and then optimization and random process. Okay, these few courses you finish. He actually finished these two courses in sophomore year, and then he go back to work on this one, machine learning and AI. Okay, machine learning and AI. So that's the low pass. You finish the fundamental math, and then you all kind of math. There are a lot of math courses you need to finish, and then you go to machine learning. And then he also took the robotics and many other course, natural language processing, and then compiler and programming language. So this one, we also have it in Lewis, okay? And this is also necessary because you need to translate between different languages. So these are some programming background that you need. And then from a business side, okay, he actually also work on quant finance. Okay, this is actually also require mathematical modeling. And then another course that is blockchain. Blockchain, let me see. He took not in this side, actually. He took a blockchain course. I forget it, which one. But anyway, if you are good in electronics and also the business side, you can use the AI. So business and the electronics, they are application for the AI. That's why this dual degree program makes sense. He also compete in data open, okay, data open. So that's the background that he has come up with. And then he now focus on AI concentration at Stanford, okay. Okay, anyway, that's what I want to say is how you can prepare yourself in college or master program in order to focus on AI and robotics study. Okay, quite a lot of math courses. Okay, quite a lot of math courses. Electronics, is that necessary? I would say optional. The double E side is optional. But if you want to build robots, drone, okay, you may need it. Okay. Finance or the business course, is that necessary? Also, this is optional. They do have a business analytics or finance. And then he also worked on, I say, the one blockchain course in Berkeley, okay? But anyway, those courses also is optional because these are application. So basically, you learn the AI, they are application. So usually application is in two domains. One is finance or business. The other one is electronics. Okay, robotics is considered to be one of the application. Okay, and then besides that, you also have the modeling that you need to do. The modeling actually is purely math. Okay, for AI, you need to learn modeling. learn how to do application. Also, you also have another one that is core CS coding, so software engineering. You need to finish. Another one is hardware acceleration, like NVIDIA. Okay, and in between software and hardware, you do have data engineering, so Databricks, the company. Okay, so if you want to go into the ecosystem of the AI, there are a lot of things that you can learn. Do you need everything? No, unless that you are really working so hard that you need everything. Otherwise, you can pick one of the domain to work on. Okay, so but if you work on software alone, is that okay right now? I would say not okay, because I would say at least you need to add some knowledge in math or application. Otherwise, the CS alone, you might be replaced by AI. Okay. Hardware, is that okay? If you only do hardware, okay, you are okay. Actually, hardware acceleration, I would say, is kind of some type of job that nobody can replace you. Okay, but basically, you have acceleration, hardware acceleration, software engineering, and the mathematical modeling and application that you can work on. Okay. So during his not talking about education. So during his study in Berkeley, he studied with no pay intern. So doing web development, okay, starting from here, he do work on some web development intern, then data science intern, then some investment company, and then go to the Berkeley AI research lab, and then IMC trading at Chicago. Okay, his one is a summer intern at Chicago. And then a cell phone platform intern, software engineering intern. And then he worked on a paper with some professor in Harvard Business School. I'm sorry. And then NVIDIA intern, right? And then he worked at Anyscale. This past summer, he worked at Anyscale. Anyscale is a company doing acceleration, but this one mostly in operation system and also programming language level. So Anyscale is a service provider for OpenAI. Okay, OpenAI uses Anyscale on top of the acceleration of NVIDIA. That's the relationship they have. Okay, and he worked on one paper at Berkeley for for NVIDIA processor for the deep learning system, big language models. And then recently he worked on a project to several tons of the TPU, okay, at the Stanford. Okay, so whatever I want to say is that it takes a lot of courses and a lot of internship. I would say he worked on more than 5 interns, also compete to get a AI fellow with some venture capital, okay? It's a lot of work that you need to do, okay, before you can win a job or a decent job in the market, okay? It's doable, but you do need to gear yourself up with a lot of courses. And what we want to do right here, okay, we just a simple 8-week course. All we can help you is that get started with the mathematical modeling for robotics, okay? And then the kind of a tool and the knowledge you learn can help you to, I would say, to group together all of your knowledge that you learned so far to use them into a right direction to help you to study in AI or robotics, okay? Any questions so far? Hello, any questions so far? If you cannot talk, you can type, okay? Let me know whether you have question or not. Any questions so far? Not so far? Okay. Okay, so I'm showing you that my son's work, okay? And then he's working on AI and robotics right now, actually. So kind of maybe similar to your age, okay? But a lot of people are working very hard to get a job, okay? That's what we need to do. And okay, talking about math and the modeling we are doing. Is that really useful? Okay, is that really useful? So given the fact that you learn some of the math, okay, some of the math background that you need, and then this LUIS course is actually a 8-week intensive course. We are supposed to cover the same material that the 16-week course covers. But in fact, it's very hard, right? It's actually very hard to learn the same material in 16 weeks. Besides that, if we check the robotic course at Berkeley, so UC Berkeley EE 106, 100 or more is actually the junior and senior course. So they do have the 100 or 106A, that's the introduction to robot. They also have the 106B, the robotic advanced robot. So basically, they do have 2 semesters. So 2 semesters times 16 weeks, they are 32-week course at the undergraduate level. I would say the difficulty is more difficult than our course, okay, because they have 30 weeks to work on, and we are 8 weeks. We are only 1/4 of the time that this course had. It had an A and B part. So it's quite challenging. We don't expect ourselves can pass them or be the same quality as the course they have. So we do have a lot of homework. We try our best. We try our best to give you the introductory course on the robotics, but that definitely is not enough, okay? Not enough. So what we expect you to really learn in this course is get used to those mathematical tools in Python. Number one, you must learn Python and PyLab. PyLab actually is a NumPy plus Matplotlib. That's the minimum that you need to learn. Also, we want you to use math well, okay, mathematics well, because Python plus math plus statistics. Okay, let me give you the whole combination. So starting from the core knowledge, Python is a programming representing the programming skill. So Python, programming skill, Python plus statistics equivalent to data science. And data science plus optimization theory equivalent to machine learning. Okay. And then machine learning plus neural network, they call it deep learning. And then deep learning plus domain knowledge, such as natural language processing, we call it AI. Does that make sense? Hello? So you start
Yes.
from
Yes, Professor.
program skill plus statistic and data sampling method. You will learn data science. You have data science, you optimize it with the past history, it becomes machine learning. Then machine learning using the neural network, we call it deep learning because you can learn for several levels. And deep learning plus natural language processing, so grammar analysis, semantic analysis, and translation, you become AI. So beyond that, that's AI, okay? So beyond that, you have the AI plus the mechanics or electronics. This will become robotics. So robotics means that you need to operate your machine and using smart AI, then it becomes robotics, right? That makes sense, right? And then robotics plus aviation, that means that you become autopiloting, so that becomes drone. So doing drone or unmanned vehicle is part of the ecosystem. You know what I'm saying? And robotics is actually also a stepping stone. So in a way, you learn things from fundamental part, okay? That's the raw path. We will build up your own knowledge, okay? So programming skill plus statistic is actually data science. Data science plus optimization theory over the past data for big data that's become machine learning. Machine learning plus deep learning for more level of the learning is called deep learning. And deep learning plus natural language processing skills, it become AI. So AI course usually is teaching the natural language processor. Okay, and then AI plus mechanical and electronics, it become robotics, and robotics plus aviation, how you drive the robot in the air, that become drone. So it's actually the whole ecosystem, how you learn the related knowledge. Okay, so what do you need to learn? There are a lot of things you need to learn. This is not a single discipline course. In a way, robotics, including CS, including EE, including mechanical engineering. This is 3-in-1 course. You cannot say that this robotics course is a computer science only course. It is not. Okay, you do need to have the electronics part. You do need to know about how the robot arm moves, right? So this is actually integral course that you need all knowledge from different disciplines. Any questions so far? And beyond these three, actually, there is a math to support all of them. Okay? You need a math of all the domain to support them. So you will see that, oh, I'm a computer science student. Why do you need me to learn so many math course and this kind of modeling? I'm not interested in this different topic. Sorry, that's the nature of the robotics. You do need to learn these. Otherwise, you cannot enter into robotics. It's not just a field, pure computer science field, including the EE mechanical engineering. Okay. Is that okay? So basically, this Monday meeting, I don't repeat whatever course that we teach in the video, okay? Because you can watch it. I don't need to repeat it. So my job right here is to help you to understand the material or to give you the fundamental background knowledge of why we are learning this and that, okay? And then today we focus on talking about the background knowledge for robotics, okay? Background knowledge for robotics. Any questions so far? No question? Okay, now go back to math. Let's go back to math. So there are so many maths. How can I get started, right? That's the problem. First, you need to learn vectors. You need to learn matrix. Okay. So you learn vector and matrix basically from the course of linear algebra. Okay. And if you learn calculus, calculus is also very important, but you do need to learn multi-variable calculus at least. Do you need to have a differential equation? I would say with the differential equation that is better. So at least these 4 math courses will be needed. Linear algebra, multiple variable calculus, differential equation. And if you know about vector and matrix, this usually is taught in the high school honor pre-calculus. These are basically the necessary course. And then with this knowledge, you can go into AI, data science, and also robotics. Okay. That's why I have my son in high school to study all of them. Okay, these are the basic knowledge that you need to get at least to go into the basic part of the AI. Okay. And then, okay. And then what does the matrix and the vectors matter in AI? Okay, first thing is, in AI, we have a lot of transformation that we need to do. Okay, and transformation means if the body object is rigid and actually it doesn't change its form, usually it can be modeled by linear algebra. Okay, usually it can be modeled by linear algebra. So the initial part, you will need to use the linear algebra. So we do use a linear algebra for what? For basic operation. So you need to know about what's mirror. There's a line, how you mirror it in the x-axis, right? Mirror. And also translation. So translation means that you have object moving from one location to the other. Okay. Third one actually is rotation. Rotation means that there's an object from here, you rotate to another location. So there are a lot of transformation that needed, and they all can be modeled by linear algebra. And these basic operations are the operations for robots. Okay, for the robots. Any questions so far?
No.
No. So basically, why we need that? Okay, you do have robot. So robot has 2 parts. The robot arm and we have wheel or track, and you have a robot motion. Okay. So for the robot motion part, you do need to build up your mathematical model of the world And then you do need to know where there are objects. So you need to avoid. Okay. So you need to have the sensor and you build a mask and you can see it. So when you move, your model also move. You need to move yourself in your mathematical model. And the model can be 3D. So you need to have a 3D tool that actually help you to model it, and that require all kind of the linear transformation. Okay. Besides that, you need to model your robot arm. So there are a lot of joint and movement. We need to model the robot arm. So basically, these are the math that we need to learn, the basic translation and the rotation. Okay, and the rotation. You need to learn how they work. That's why we need those kind of math. So talking about a translation, okay, talking about a translation. So we do have a object right here. Let's assume this object is at the point of xy. Okay. And you move from this point to another point with a vector of AB. So the new coordination on this point will become x plus a y plus b. So this is a vector addition of the coordinate of this point with the vector. Does that make sense? So let's assume that the new coordination is called big X, big Y. So big X would be equals small x plus a. Big Y would be equals small y plus b. So you can write down as x, y, big X, big Y equals small x, small y plus a, b vector. Does that make sense? So this is given the fact that your object moved from xy to a new location with a vector of AB. Okay. On the other hand, you may have some time you are here, you are in the car. Your car moved from here to here, but there is an object right here. Let's assume that you, in your original observation window, XY, this location is called AB. I'm sorry, this location, let's call it XY. Okay, but your car moved. Your car moves, so you do not stay in the same location. So your new coordinate system is XY right here. So for it to see, it will actually will see this XY point with a new destination of XY. Okay, so the object doesn't move, your car moves, your observation window moves. Okay, let's assume that this movement is also AB. Your car do move AB. I'm sorry. This is not good. Your car do move AB. Okay. The object doesn't move. The object stay in the original location. Okay. So your new observation and the original point, the relationship is that you move from here to here. So let's assume that your original point is 0, 0. Now your original point move on to AB. So the relationship of these two actually is your XY will be equal to your original XY minus the AB. So your big X, big Y will be equal to small x, small y minus the AB. So what I want to say is that your coordinate movement is similar to the minus movement of the object. In fact, the object doesn't move. So, but in the mathematically, it's in opposite location. Okay, it's the last time we talk about the object move from xy to new x, new y. That's the same xy location. Okay, UH plus AB. But now your observation window changed, so you actually minus the AB. Did I make sense? Hello? Any question? Okay, this is translation. Okay. Next one is rotation. So rotation actually when we have one object right here, we rotate a theta. So that's the original angle is right here. Okay. So the length is R. So this coordinate should be AB, but this AB would be equal to R cosine phi, R sine phi. And the new point, okay, new location right here, it should be, let's assume it's X, Y, big X, big Y. It will be equals R cosine theta plus phi. And R sine theta plus phi. So that's the notation. Okay. Any questions so far? No. Then let's compare. If you originally have a coordination like that, your point is right here. Okay. So originally you have this phi right here. Now your coordinate doesn't move. I'm sorry, your object doesn't move. Your coordination actually rotate this way. So your new x is right here. Let me use a different color. So your new x location is right here. Your new y coordinate is right here. So you move down by theta. Then in the new rate coordinate system, you do have the theta plus phi. But this is you rotate counterclockwise for your object. This one is your friend, your observation friend, rotate for clockwise theta. The same the mass is the same. Does that make sense? So usually we do have the calculate the observation window or frame based on this mass. So we do have those kind of mass in our video. So you can watch and learn how these different frame change to get different coordinate. Does that make sense? Any questions so far? And this is 2D, this is two-dimensional. Okay. Any questions so far?
So just to clarify real quick then, regardless of the rotation clockwise or counter, it would still be r cosine of theta plus 5?
No, but that's not what I say. What I say is that if your object move from the angle theta, phi right here, to with the angle of theta, your object move from here to here, right? So your new coordinate would be r cosine theta plus phi, and then y would be r sine theta plus phi. Is that okay?
Yep.
But mathematically, if your object don't move, but your observation window move, so you move counterclockwise by theta, then this original point's new coordinate in the red coordinate would be similar to your object move. That two is different. One is object move, one is the observation frame move. But mathematically, these two are the same. So right side is the car move. Left side is car don't move. We change the angle or change the location to look at the card. Two mathematically are similar or identical. Does that make sense?
Yeah.
So why we need this, okay? Why we need this kind of mass? That's because we do have a lot of robot joint. So that's assume that we just have a 2D, okay, two-dimensional robot. So here you have a wheel, a rotor. You have another rotor. So right here, you do have a XY that you want to look at, right? But at this location, your XY axis is changing. And then in this location, the XY can be changing. That means that if you rotate, the red XY can also rotate. If you in here, your blue XY may also rotate. If you rotate, does that make sense?
Yep.
So the destination of this point right here, your robot finger. Your robot finger, when you need to know about where it is, you need to calculate based on this rotator, and with respect to the ground. So you do have frame 0, frame 1, frame 2, frame 3, 4 frames, 3 coordinate or rotor, but you do need to have 4 frames to model it. So each one of them you need to use metric to model it and do the rotational difference. Does that make sense? That's why we need to talk about this translation. And so there are two types of the joint primarily. One is extendable part, your robot arm or the lens will move. So you process distance. So those are called prismatic joint. Another type is you do rotation. So that's rotational joint. And in a way, this one is translation, this one is rotation, but you do need to use both kind of the mass to model your robot arm. Right? And your robot may be on top of a car, a tractor. Then in movement, if you got the movement, your robot location also be moved. So that's a very, very complicated, a lot of metric operation. Because it demands so much metric operation, so you need the GPU, right? NVIDIA GPU to help you. Does that make sense? Does that make sense? Any questions so far? Hello? Any questions so far?
No, Professor.
Okay, so for the detail how the mass calculate and how you actually do mass modeling, we do have the homework and the video in the course that you can watch. Okay, so I don't repeat it. But today our main purpose is to teach you the motivation and also the background knowledge of why we are doing this, why we calculate so much of the mass in order to calculate the coordinate. Okay. Any questions so far? Okay, if no question, I would stop right here. Okay, give you more time to study and let me know if you have question. Okay, so basically, the kinematics. Okay, let's go back to the slices. Okay, the slices that we use. The chapter 2 kinematics is talking about the representation of the orientations. Okay. So here it teach you all kind of metric operation and the degree of freedom and all kind of mathematical calculation for rotational metrics. Okay, this one is graduate school material. So there are a lot of metrics, very difficult. So I suggest you, if you don't understand it in the beginning, you don't understand it, what you should do is that you watch the other set of the material, that's undergraduate material. So let's see. You can see that in the lab, I do have a lot of, let's see here. No, not this one. Okay. So you see this blue and orange one. This one is undergraduate material. So right here, it teaches you the more basic one. You can see that it actually is easier. Is that okay? Hello? Is that okay? And
Yes, but
there are tons of material, so I cannot do them, okay? Too much. You have to watch the video. Okay? Okay. Any question? If not, I do welcome you to contact me by email or send me messages through the Facebook, okay? And a lot of things you need to figure out by yourself. trying to go through that. And one student asked me about the project, okay, the turn project. Our project is always open project. So we don't give you guideline. You can do whatever you want to do as long as it's related to robotics, okay? And be creative. We don't want to give you a specific topic of you should do this and that. You should find the project by yourself, okay? Unless like you bump into some trouble, say, oh, I don't know how to do this. You can ask a question like that, but we don't pick a topic for you because creativity is part of the estimation, the matrix that we use to measure the good or bad of your project, okay? We see, look at how creative you are. Okay, any question? Okay, if no question, that's it for today, okay? See you next time. Bye-bye.